right, welcome back to day 4 of our ACT Prep Unit 4 Intermediate Algebra topics, and today we're going to be talking about rational and radical expressions. All right, simplifying expressions. To simplify rational and radical expressions, you may need to use some or all of these equalities. So these are things that you need, rules, laws, if you will, about exponents and things that you need to know. If I take this symbol, that means the nth root of x. If I take the 8th root of x to the b, you can get in and out of the radical. To get out of the radical, you take your base, which is x, the exponent becomes the numerator, and the index becomes the denominator. So like if I had the cube root of x squared, that would be x to the 2/3. Okay? This is the 2 is the numerator, 3 is the denominator. If you have anything to a negative exponent, you can't leave that in your answer. It's illegal. So what you do is you just move floors. So if x has, I call it having a bad attitude, right? This guy's a hater. He's got negative attitude all up in his business, and we got enough hate in this world. So we're going to say, get away from me. I don't even want to be near you. So right now, if you made this a fraction by putting it over 1, what you say is, get away from me. Go to the basement. So we send him downstairs, and that adjusts his attitude. And notice that it's no longer negative. If it was in the denominator to begin with a negative exponent, you can't leave that there either. So if he's downstairs with a bad attitude, again, we say, get away from me. We send him upstairs, which adjusts his attitude and makes it positive. So if I gave you 4 to the negative 2, that would really be 1 over 4 squared, which would be 1 over 16. If I gave you 1 over 4 to the negative 2nd, that would be 4 to the positive 2, which would be 16. Okay? If you have the square root of x times the square root of x, basically it erases this, because this is really the square root of x squared. Well, those 2's cancel, and I get x. And it says when the bases are the same, if you're multiplying and dividing, when you multiply powers, if the bases match, you keep the base and you add your exponents. When you're dividing, you keep your base and you subtract your exponents. Okay? Undefined expressions. Okay? This has to do with domain. And basically, any expression is considered undefined when its denominator is equal to 0, or anytime there's division by 0. Otherwise, the expression is defined, which isn't really true. When you have radicals, that creates some more drama, but apparently for this ACT prep, they don't consider those restrictions on a function. So even though I have a hard time ignoring those other restrictions, for this ACT, all they're worried about is anything that makes your denominator 0. So when it asks you to figure out where your function is not defined at, you just tell yourself, Mr. Denominator, you may never, ever equal 0. And when you do equal 0, we throw you out. We can't include you. So for this, they want me to know when it's defined. Well, all I do is say, Mr. Denominator, you may never equal 0, which means that's the only place that it's not defined. So this is defined everywhere except when x equals 0. Okay, this is defined for all values of x, because if I take the denominator, 3 to the x, and say you can never equal 0, and I solve this, to get x, I need to get x out of the air, for one thing. Okay? Let me change colors here. Well, it's an exponent. If I want to get rid of an x power, I take the x root. But I got to do it to both sides. That cancels it and gives me 3. Any root of 0 is 0. Well, this is silly. 3 will never equal 0. This can't happen. 3 can never equal 0. If it can't happen, then there is no drama, which means it's defined everywhere. Okay? So on this one, I take my denominator, x minus 8, and I say you may never equal 0. Add 8, which means x may never equal 8, which means that the function is defined everywhere except for when x equals 8. Okay? All right, so to simplify this, you can't divide 11x by a radical. Okay, so there's a law that says you can never, ever, ever leave a radical in a denominator. So what they're telling me to do basically is rationalize the denominator. And you know, I mean, it's nice if you understand the language, but basically when you see a problem that has radicals in the denominator, you have to get rid of them. Well, all you do, that's the square root of 3x minus 8. If you want to kill a square root, you multiply it by itself. So if I multiply by the square root of 3x minus 8, which you can do anything you want to a fraction, as long as whatever you do to the bottom, you also do to the top. On top, you can't, it's not like you can take 11x times 3x. You don't actually multiply, you can just make them touch. So you have 11x times the square root of 3x minus 8 over, this is going to be the square root of 3x minus 8 squared, because 3x minus 8 times 3x minus 8 is 3x minus 8 squared. And when you take the square root of a square, it cancels, and that gives me 11x square roots of 3x minus 8 over 3x minus 8. But I mean, it doesn't look any simpler to me either. But we've eliminated the radical in the denominator, so we're good. Okay, so now on this one, they want me to simplify. Well, my suggestion to you, what I always do is I get things, I'm going to rewrite everything. In, like you've got things written in radical form and you've got things written in rational exponent form. So the first thing I'm going to do is I'm going to rewrite this and get this into rational exponent. So I have 1 over x to the negative 2/3 plus this will be x to the 2/3 over x to the negative 1/3. Okay? So now what you're going to do, for me, all right, I am going to get these negative exponents gone. So move floors. That would move him upstairs. Adjust his attitude. This is going to move upstairs, so that's going to be x to the 1/3 times whatever else is up there. I mean, there was already x to the 2/3. I just moved him up, and if there's something already there, you just multiply them together. Okay, so this becomes x to the 2/3. This becomes x to the 1/3 plus 2/3, because when you multiply powers, you add exponents. So that's x to the 2/3. Plus x to the 3/3. That's x to the 2/3 plus x, because 3 divided by 3 is 1. And that's as far as I can go. Okay? And again, you're simplified when you no longer have negative exponents and all of your radicals are in simplest form. This one says, for which real values of this function is it defined? All right, well, again, you say, Mr. Denominator, you may never equal 0, and then you solve it. So what I'm going to do is I'm going to add 8, and I get 2 to the 4 minus x can never equal 8. Well, my problem is, how in the heck am I supposed to figure out what x is? It's up in the freaking air, for crying out loud. Well, there's a law that says if you want to, without using logarithms and all of that stuff, which is way beyond what we need to do, if I could somehow make this side a 2, which I can, if I break that down by 2 is 4, by 2 is 2, I can rewrite 8 as 2 cubes, right? So now there's a law that says when the bases match, and you have powers, and I don't mean, when I say power, I don't mean the exponent. This whole thing is a power, and this whole thing is a power. When you say that two powers are equal, and you have equal bases, there's only one way that this statement is true, and that's if whatever's in the air on this side is equal to whatever's in the air on this side. So what I'm really saying is 4 minus x can never equal 3. So to get x alone, I'm going to minus 4. That gives me negative x can never equal -1. So then, if I divide by -1, I get x can never equal 1, which means my expression is defined for all reals except x equal 1. Okay? So this is defined for all reals except x equal 1. So, I don't know, you got to see how they ask you a question. The values of x which the expression is not defined would be when x equals 1 is not defined. Okay? Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got, my pen catches up, x plus x to the 1/2. Okay, so the first thing I did, again, was I got out of my radicals. So this would be x to the 3/2 plus x, then the bottom would be x to the 1/2. Okay, and then when you have a binomial on top divided by a monomial on bottom, you basically, to simplify, you have to divide them both. So this is going to say x to the 3/2 divided by x to the 1/2 plus x to the first divided by x to the 1/2. Now we're going to use our division rules that say when you divide powers, you subtract exponents. So that's 3/2 minus 1/2. And this is x to the 1 minus 1/2. So 3/2 take away 1/2 would be x to the 2/2, which is x to the first. This one, I'm going to need a common denominator, which is going to be 2. So to make it 2, I'm going to multiply by 2, multiply by 2. That's x to the 2 over 2 minus 1 over 2, which makes x to the 1 over 2. And there's my answer. Okay? Alright, so now we just got a bunch to practice on. Okay, just to show you some tricky tricks. Alright, on this one, you could move this down if you wanted to, but when you divide powers, you keep the x and you subtract exponents. -3 minus 3. Get this out of the radical is going to be x to the 2/3. This is going to be x to the -6 plus x to the 2/3. And that's all I can do, but you're not allowed to leave negative exponents in your answer. So I'm going to move him to the basement, which gives him an attitude adjustment, makes his -6 positive, plus x to the 2/3. And that's as much as I can do. Okay, same with 2. It's easier to get them out of radicals. So this is going to be x to the 3/3 minus, when you divide, you subtract exponents. That's going to be x to the 4 minus 4. Well, this is x to the first. This is x to the 0. Anything to the 0 degree is 1. And done. Alright, so on 3, again, the first thing I like to do is to get rid of anything in radicals. So I have x to the 2/5 minus x to the 3/5 divided by x to the 1/5 plus 1. Now, order of operations says that I have to do my dividing before any adding or subtracting. When you divide, you subtract exponents. So that's going to be 3/5 take away 1/5, which is going to be x to the 4/5. Okay? Then I can bring everything else down. So I have, what's a negative? X to the 2/5 here plus 1. Okay? Oh, what am I saying for? 3 minus 1 is 2. Well, x to the 2/5 take away x to the 2/5 cancels out, and my answer is 1. Okay? Okay, now 4 is, my colleagues and I were talking about this problem for several hours last night because I do not get the same answer. I can get the same answer that the book gets if I do it with radicals, but I do it with rational exponents, which gives me a different answer, which is very interesting because, and all of us did the same thing. So anyway, I guess I'll do it like the book does it. What the book says is you can't multiply or divide radicals unless the indexes match. And you can make a match. So I could rewrite this as x to the 2/3 times x to the -1/2 divided by x to the 5/6 times x to the negative 2 over 3. Basically, what you want to do is get a common denominator, which would be 6. So times 2 times 2, that would be x to the 4 6. Times 3, that would be x to the negative 3 6. Divided by, that one's done, times 2 would be x to the negative 4 6. So now if I go back to radical, this is the 6th root of x to the 4th times the 6th root of x to the negative 3rd divided by the 6th root of x to the 5th times the 6th root of x to the negative 4th. Okay, so now this one, you take a 6th root times a 6th root is a 6th root of x to the 4th. When you multiply, you add. 4 minus 3 is x. Okay, then I've got to divide next the 6th root of x to the 5th. Well, when you divide, you subtract exponents. So this would be the 6th root of x to the 1 minus 5 would be negative 4. Then times the 6th root of x to the negative 4th. I'm still going to get the same answer. That would be the 6th root of x to the negative 4 plus negative 4 would be negative 8. Oh, no, I got the right answer now. Okay, so now if I get out of radical, that's going to be x to the negative 8 over 6, which is x to the negative 4 thirds, which is 1 over x to the 4 thirds. That is what the book got. But if you did this in rational exponent form, you'll get 1. And I think that the answer is just as correct, actually. All right, so on 5, I'm going to rewrite everything. So I have x to the negative 5th plus x to the 5 over 2 divided by x to the 1/2 minus x to the negative 10 over 2. Okay, I've got to do the dividing first. So that's going to be x to the 5/2 minus 1/2. That's going to be x to the 4/2, which is x squared. Okay, bring everything else down. So I have x to the negative 5th here. This simplifies to x to the negative 5th. Those cancel, and I'm left with x squared. All right, on 6, get out of the radicals. So I'm going to have x to the 2 thirds plus x to the 3 thirds times x to the 1 third. Okay, I've got to multiply first. So that's going to be x to the 3 thirds plus 1 third, which is x to the 4 thirds plus x to the 2 thirds. And that's as much as I can do. So we are done. All right, on 7, I'm going to rewrite it. So I have x to the 1/2 times x to the negative 1/2 plus x squared. All right, we got to multiply first. So I have x to the 1/2 plus a negative 1/2. That's going to give me x to the 0, which is 1. And then bring this down, plus x squared, and we're done. All right, on 8, I have x to the 4th times x to the 1/4 plus x squared times x to the negative square. All right, order of operations, we have to multiply first. This is going to be x to the 4 plus 1/4 plus x to the 2 plus a negative 2. When I add those, all right, if you do your crisscross straight across, all right, or get a common denominator, which is going to be 4. So times 4 times 4, this would be x to the 16/4 plus 1/4, which is x to the 17/4, plus this is going to be x to the 0, which is 1. So that would be my solution. Number 9, all right, this can move up. So I'm going to get x to the 6th. Get out of the radical. That's going to be x to the negative 3/2 divided by x to the negative 3/2. times x. Well, I'm going to have to multiply and divide in order from left to right first, so I'm doing this, which is going to give me x to the negative 3/2 minus a negative 3/2. The double negative is going to turn positive, and that gives me x to the 0, which is 1. Okay, so then I have, bring everything else down, I have x to the 6th plus 1 times x, so that is x to the 6th plus x. And you can't add a 6th degree to a first degree, so we're done. Okay, so on 10, if I get out of the radical, that's going to be x to the 2 over 2 plus x to the 2 over 3 times x to the 2 over 4 divided by x to the 2 over 5. So, order of operations, I'm going to multiply first. That's going to give me x to the 2/3 plus 2/4. I need a common denominator. This is a little trick I learned. If one of them is not a whole number, you just crisscross straight across. If you want a common denominator and don't want to think about it too much, just do criss. 2 times 4 is 8. If that's a plus, it's plus. If that's a minus, it's minus. 3 times 2, that's cross. Over straight across, 3 times 4 is 12. That's x to the 14 over 12, which reduces down to x to the 7 over 6. So now we bring down x to the 2 over 2, and we have that divided by x to the 2/5. Okay, so the next thing we have to do is divide, and that's going to be x to the 7/6 minus 2/5. And if I do my crisscross straight across again, I'm going to come over here and do it. Okay, that's going to be x to the criss, 7 times 5 would be 35, minus 6 times 2 is 12, over straight across would be 30. That gives me x to the 23 over 30. So this is x to the 23 over 30 plus, this is just x to the first. And I can't combine them. We're done. Oops. All right, on this one, identify the real values. You're saying Mr. Denominator can never be 0. Well, that can't happen, so there's no drama, which means this is defined for all reals. There's no restriction. Okay, again, on this one, you've got some restrictions here, but with a different variable. Anyway, we're just focusing on the denominator, so you say, Mr. Denominator, you may never equal 0. Solve for x, which says x can never be 0. So this is defined for all reals except when x equals 0. Okay, on 13, Mr. Denominator, you may never equal 0. Add 2. 6x may never equal 2. Divide by 6. X may never equal 1/3. So this function is defined for all reals except for x equal 1/3. Okay? Alright, 14 and 15. Again, I take this denominator, 3 to the x plus 2 minus 3 can never equal 0. I'm going to get this alone, so add 3, 3 to the x plus 2 can never equal 3 to the first. And again, we can apply that law that says if the bases are the same, the exponents have to be. So I'm saying x plus 2 can never equal 1. Minus 2, x can never equal -1, which means this is defined for all reals except x equal -1. Now, 15, when I first started, I was like x cubed plus x squared plus 18 can never equal 0. My problem is we don't have any factoring techniques or any other kind of techniques to solve a third degree equation. Well, we do, but the P over Q and the rational zero theorem and all of that is way beyond a minute problem you want to do on an ACT. So what you can always do to figure out when something equals 0 is graph it. And look where it crosses the x-axis. So I went to y equals and I typed in my function. I set my window. I had to play a little bit so I'd get a good picture. All right, and then you'd see this cubic function. The third degree function will make that S looking shape. And right there is where I'm looking for. I don't want this to can't equal 0. So I calculate the 0, and then you do left bound, right bound, and right there, and you will get a 0 when x equals 3. So what this says is x can never equal -3, or you'll get 0. And what that means is this is defined for all reals except x equal -3. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got D. Okay, which of the following expressions is expressed in simplest form? Well, I'm looking at my solutions, and clearly most of them, except for these two, got rid of the denominator. So what that tells me is there's probably a GCF in top, and there sure is. On top, my GCF would be a 4, 2 copies of x, and 2 copies of y. If I GCF that out, what you're doing, let me write it to the side here, is you're dividing out that 4x squared y squared, 4x squared y squared. Whatever is left is your other factor. Remember we just went through a whole factoring thing? Alright, so the 4's cancel. X cubed divided by x squared is x, and the y squareds cancel. Plus, the 4's cancel, the x cancels, and the y cubed divided by y squared is y. So that's all over my original denominator, which was x plus y. Those cancel, and that's what's left in simplest form. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 0. All right, this is going to be 1 over x to the 1/3 times x to the 1/3 minus x to the 1/2 times, this would be the square root of x to the -1st. Okay. Well, guys, on these ones, these cancel out and I just get 1. Okay, or you could do this over this and subtract and blah, blah, blah. Okay, that's going to be minus x to the 1/2 times x to the -1/2. I have to multiply next, which is x to the 1/2 plus a -1/2, which is x to the 0, which is 1. And 1 minus 1 is 0. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got it all reals. I have to say, Mr. Denominator, you may never equal 0. Well, there's no way I can make this a base of 2. You can't break 0 down into 2's. So if I try and do, well, I'll take that root, knowing that any root, I don't care what it is, of 0 is going to be 0. That says that this would cancel that, and I'd have 2. Well, this can't happen. If that can't happen, there is no drama, which means it's defined everywhere for all rails. Okay, try this one. Hit pause. Come back when you're ready. And come on. Hopefully you got J. So I take my denominator, x squared plus x minus 6 can never equal 0. To solve this, it should be an easy factor because a is 1. So x, 2, and 3 make 1. My c is negative, which says they have to be opposite, and Bully will take the middle, so he's positive, he's negative. So x minus 2 can't equal 0, and x plus 3 can't equal 0. So x can never equal 2. And this says that x can never equal -3. And y, does it say all negative real numbers except for 2? Huh. Oh, See, and then, okay, actually there should be two restrictions. X can't be 2 and X can't be negative 3. Well, but that's true anyway because X can't be a negative. And there's a couple problems in this section that I do not agree with this author on. This should say all reals except X equal 2 or X equal negative 3. I'm not really sure why they're only saying one of them. All right. Try this one. Hit pause. Come back when you're ready. And hopefully you got B. Okay, again, I'm looking at this. None of my answers have denominators, so I'm assuming I can factor the top, and I can. Okay, let's say that I'm going to take this negative and a 2, and that's what they have in common. If I GCF by negative 2, that's going to give me X squared, and then by negative 2 is going to give me minus Y squared. And you're going, well, that doesn't cancel the top, but if I factor the top, this is difference of squares, that's going to be negative 2, bino, plus n mino, x plus y, x minus y, all over x minus y. The x minus y's cancel, and I'm left with negative 2 times x plus y, which simplifies to negative 2x minus 2y. Okay? All right, and we are done, so I will see you next time for day 5.